So given some arbitrary epsilon greater than 0, we need to show that there exists some positive number delta such that absolute value of 4x plus 1 minus 9 is less than epsilon. Last time we talked about if 4x plus 1 is approaching 9, eventually it has to get really, really close to 9. You can't approach 9 without getting really, really close to it, eventually. So 4x plus 1 is approaching 9. Well, how close do we want it to be to 9? Well, let's say it's got to be this close. This close. It's got to be within epsilon of 9. So the difference between 4x plus 1 and 9 is less than epsilon whenever absolute value of x minus 2 is less than delta. Now, we put in this 0 is less than basically all the functions that we consider, unless I just make up some off-the-wall piecewise function for us to spend some mental gymnastics with. Most of the functions we consider are going to be continuous functions, so that they're going to be defined at this particular point, and they're going to be defined to equal the value of the limit. So the 0 is less than really is not going to come into play all that much. But what it's saying is that this doesn't have to be true exactly at x equals 2. It just has to be true really, really close to 2, when x is really, really close to 2. But the 0 is less than turns out not to come into play very much for the examples that we consider in this class. All right, so scratch work. Find a delta. Find a delta that works. So here we go. Absolute value of 4x plus 1 minus 9. We need that to be less than epsilon. So we're going to have control over this expression, absolute value of x minus 2. So we're going to try to express the absolute value of x minus 2 in terms of epsilon somehow. So we simplify. This is the absolute value of 4x minus 8. That's got to be less than epsilon. Now, there's two steps I'm going to skip. Factor out the 4, use the property of absolute value, and then eventually the 4 comes out in front, and we have 4 times the absolute value of x minus 2. We want that to be less than epsilon, so that means that x minus 2 really needs to be less than what? Epsilon divided by 4. So we need that to happen. Well, in order for that to be true, let's let delta equal epsilon over 4. And now for the actual proof, show that delta equals epsilon over 4 actually works. So we got our scratch work. The scratch work produced a delta. So we think maybe, yeah, if we decide how close 4x plus 1 needs to be to 9, then divide that by 4 and make sure x is no farther away from that than 1. So show that epsilon over 4 actually works. So suppose 0 is less than the absolute value of x minus 2, and that's less than delta, which we are going to let equal epsilon over 4. Suppose that's true. We're supposing that, but we've got to show whoops, that's not red. We've got to show this. Once we show that, that's the punchline. We're done. So here goes. What can we say about the absolute value, wrong shade, absolute value of 4x plus 1 minus 9? I want to show it's less than epsilon. What I know is that it's equal to the absolute value of 4x minus 8. It's equal to that. I know we can factor out a 4. So it's equal to that because 4 is positive. And off to the side over here, somewhere inside our scratch work, more scratch work. I'm not going to draw a bubble. Maybe what? A scratch octagon. That's going to be rough looking. How many sides does that have? Is that a nonagon? Anyway, whatever shape that is, what we need is this. Suppose we know the absolute value of x minus 2 is less than delta. That's what we're assuming. What happens when we multiply both sides by 4? Four times the absolute value of x minus 2 is less than 4 times delta. That's kind of key. I found in the past that's the hardest step in the entire process for students to see when I have this and just jump down and say that. It's different looking at it vertically than it is horizontally. Horizontally, I think it's clear. We have absolute value of x minus 2 is less than delta. We're assuming that. Multiply both sides by 4. What could be clearer than that? Multiplying both sides by 4. But here it's like we got a top and a bottom, and we multiply the top and the bottom by 4. The way they're arranged there on the page. I think it's just the way they're arranged on the page. If that's the least bit tricky to see there, I think it's just the positioning. What's delta? Epsilon over 4. And 4 times epsilon over 4 equals epsilon. Rough looking epsilon there, but there it is. So that's the conclusion. If x is less than delta units away from 2, then 4x plus 1 is less than epsilon units away from